Now that we have finished look at the modes of degradation, let us now look at overhead poles and lines condition assessment. Now, because a pole failure in service not only impairs dependability, but also poses highly serious and life-threatening safety hazards, structural supports in the form of poles play a dominant role in determining the overall health index for a line section. The detection of deterioration in wood poles, as well as the assessment of the pole's remaining strength and useful life, is a topic that has received a lot of attention in the past 10 to 20 years. And the possibility for substantial change in the original mechanical properties of wood poles, which is a natural material, is a specific issue when assessing their condition. The design procedures or safety concerns in selecting pole class, tree species, kind of wood preservatives applied, regional precipitation, humidity levels, and soil drainage all have a role in determining the normal pole life expectancy. The amount of continuous leakage current passing through wood poles and through polluted insulators may impair the condition of poles in specific situations. The mechanical strength of a new wood pole varies substantially depending on the species. For poles presumably in the same class, the first standard deviation typically has a width of 15%. However, the minimum measured strength for the same kind and vintage of pole has been as low as 50% of the average in some test programs. Now, the assessment process begins with a simple visual evaluation of the wood poles, followed by basic physical testing such as poking test for surface condition and hammer test for internal decay indications. Many utilities use this method largely as a safety process for alignment to follow before climbing. Clearly, these simple tests are subjective, but they are quite useful for detecting wood degradation and identifying questionable poles when performed by competent personnel. In many cases, power companies have utilized similar techniques to evaluate if poles are nearing or have reached the end of their useful lives, as well as the necessity for pole replacement. Electricity companies, on the other hand, have sought more objective and reliable methods for detecting condition and calculating remaining life over the last 20 years. As a result, a variety of condition evaluation and diagnostic instruments and techniques for wood poles have been developed. And these approaches include those aimed at making traditional probing or hammer tests more controlled, repeatable, and objective. Instrumented hammers record and analyze the vibration created by a hammer blow and discover patterns that indicate the severity of decay, while devices that measure the resistance of a pin fired into the pole to evaluate the severity of external rot are available. And the use of a decay resistance drill or an auger to take a sample from the pole for direct examination is also very common in the utility world. Now, before we move on further into our course, let us take a brief look at our sponsor for this course. Now, as an engineer, especially when I first started in my career, I really felt overwhelmed the list of documents that we need to do on top of our technical work. Yet, these documents are very important in our career as it is the more prominent thing that displays our credibility to management and to our clients if we so decide to become an engineer consultant, which is where the real actual money is. Now, I don't have these tools available to me when I first started my career, but now PM Milestone has created this package of all the professional templates that you need so that you can focus more on the technical aspect of your career. These templates are tried and tested by real professionals, so you should feel confident in using them in your career to present your best foot forward in front of your manager or clients. These templates are also updated periodically, and I think their last update is just 2021, so they're not going to be out of date or context to the present times, as these people are serious in getting the most professional product to meet your needs. They're also very confident of the quality of these templates too, as they offer you their product completely risk-free with 60-day money-back guarantee if you are not satisfied with it. So, If you are interested in this product and would also like to support me in creating these courses on YouTube in the future, please check out their product using the link in my video description titled Course Sponsor PM Milestone 2.0. Ultrasonic, X-rays, and electrical resistance measurement tests are examples of indirect, non-destructive test procedures for assessing the quality of wood poles. Ultrasonic technology in particular has sparked a lot of interest, leading to the development of commercial instruments that are utilized by a lot of power companies. The attenuation of ultrasonic signals allows moisture content measurements to detect internal deterioration and reflections at interfaces to detect voids using ultrasonic techniques. The utilization of radar and laser technologies, as well as initiatives to establish helicopter-based evaluations, are all being used to improve condition assessment methodologies. Such approaches are now at the experimental stage and implementing stage in some utility companies. Many companies have embraced one or more of the available evaluation approaches, created practical protocols for the implementation, and are now generating consistent results that are utilized as the foundation for condition assessment. The fact that most of these strategies predict a drop in mechanical characteristics relative to a new pole is a shortcoming of this methodology. However, because the mechanical strength of new poles varies greatly, this is not the same as being able to determine an individual pole's mechanical strength. It is standard practice to use an average value and then use a rather large factor of safety, which is from 2 to 3.5, to account for the substantial variability in the strength of new poles. Utilities frequently use geographic information system-based data management and recording technologies to assess the state of huge pole populations, in which the basic identification information and global positioning system coordinates are recorded. The pole type, setting arrangement, class species, height, date of installation, and initial treatment type are all recorded as background information. The inspection procedure allows you to record an environmental code, past maintenance work, and the results of the test you ran. The type and number of attachments at each pole, as well as specific flaws in the pole structure, are all recorded as well. A pole damage checklist is also going to be available to the crews, which covers wildlife damage as well as other physical damage to the pole. To demonstrate the definitions for each category, photographs are provided as a reference by the field crews usually, and any harm is categorized as a mild, moderate, or severe. Damage caused by animal activity or other non-rot related processes can be classified and making it easier to identify poles that need to be replaced. Direct measurements, which are things such as external rot or shed thickness, are taken at 3 points around the circle at or just above ground level in the case of wood poles. The thickness of the shed is measured to the nearest half inch, while the thickness of the outside rot is measured to the quarter inch. The degree of corrosion on steel poles is frequently used to determine degeneration or rust. Corrosion at the ground level or below the grade provides useful information regarding the pole's status in this regard. As a result, the most effective method for assessing steel pole status is to do visual examinations for below-grade corrosion while partially excavating the surrounding soil. Visual inspections can detect concrete spalling or rebar corrosion when assessing the condition of concrete poles. Wood crossarms deteriorate in the same ways that wood poles do. Corrosion and the loss of strength due to rusting are the most common modes of degradation for steel crossarms and hardware brackets. And during line patrols, routine inspections can be used to examine the condition of crossarms and hardware. Visual examinations can also give you a decent idea of how well an insulator is doing. Visual inspections can reveal the degree of surface pollution or flashover symptoms in porcelain insulators with broken or fractured sheds. Any degradation induced by corona can be identified using PD scans in the case of composite insulators. Hardware components that have corroded or are missing can also be recognized. Although conductors have a longer service life than poles and insulators, the remaining tensile strength of conductors on lines built with small size conductor or ACSR conductors can be assessed through routine tensile strength measurements in a mechanical lab. Visual inspections can also show spans with low quality splices or bird caging, although such flaws are usually rectified with localized emergency repairs and do not influence the line's overall health index. Now, if you like this video, please don't forget to click like and subscribe to our channel. Our channel, the EE Bootcamp, has a wealth of knowledge regarding to the energy industry, so be sure to check it out. Also, this video is part of a playlist of the whole course, and so I've put the link to the playlist for this free course in the video description. As you may be aware, I'm a professional online instructor that teaches various topics regarding to the energy industry and offers certificate of completion at the end of each course. As you probably have noticed, this course needs fundamental knowledge in basic asset management. Physical asset management is important, and the skills are highly sought after in many large companies within the energy industry, or any industry that manages large asset in infrastructures for that matter. If you lack knowledge in physical asset management, look no further than my Physical Asset Management Fundamentals course offered at Electrical Engineering Portal, as in that course, I will provide you with the fundamentals that you need to kickstart your career in the physical asset management world. Another type of knowledge that you need for this course is fundamental information about the power distribution system. If you don't have enough experience in the industry, I would suggest you to enroll in my Distribution Power Engineering Fundamentals course hosted on Udemy, as in that course, I will walk you through the different parts of the power distribution system as well as basic design concepts that you will need to kickstart your career in the industry. Now, I have put the links to both of these courses in the video description also. Lastly, I have also included the link to my website in the video description that contains the information to all the courses that I offer, as well as other helpful resources that you may find useful in your career or in your learning path. Thank you, and I wish you good luck in your career. Remember, knowledge is power.